So the topic that I have selected for the day is ISRO's glorious achievements over the years and what all it teaches. So we talk about achievements. So can we say that all achievements can script history? Let us take an example. We talk about Novak Djokovic, who is a famous tennis player. And he has been used to get a lot of Grand Slams, right? And he has become a champion, or has become a Wimbledon champion. Probably 4 years back we would have been more impressed, but now I think it has been a used story, right? He has almost 24 Grand Slams. But when we say Carlos of Spain, Carlos Alcaraz of Spain has beaten Djokovic and become a Wimbledon champion, and that has created a history. Because when we talk about achievements, we tend to make a comparison, and that is a human habit, right? We do have some comparisons. A comparative thing is there behind any kind of achievements which can create history. So what is the relevance of ISRO's achievements in this? Does it have any comparison? Is it have a comparison with other space agencies or something else? Probably what I can tell you is ISRO's achievements is comparable with its past. Do we think that the kind of glitterings and lustrous outlook that ISRO is having today, was it having in the past? Probably the next slide. Can we ever imagine ISRO had started its office and laboratory in a church called a St. Mary Magdalene Church in Trivandrum, where we have the Tumba Equatorial Rocket Launching Station? We know why Tumba was selected for launching sounding rockets, because it's close to our magnetic equator, and there are a lot of technical reasons why we have selected Thurles or Tumba Equatorial Rocket Launching Station as the area for launching our sounding rockets. Can we have next slide? The Indian space dream started like this. It had humble beginnings. We have some pictures over here. You can see some of the spacecraft components and satellite launch vehicle components being taken in bicycles and bullock carts in the initial period. So we never had the luxury of great infrastructures and buildings those times. We can see Dr. Vikram Sarabhai, who is the father of our Indian space program, discussing with none other than our former president, Dr. APJ Abdul Kalam. And unlike other space agencies, ISRO's pioneers dreamt of making lives better through space, and this vision was to harness space technology for humankind. This is the speech that our father of our Indian space program, Dr. Vikram Sarabhai, had given. This event was in 1968, 2nd December, when Thurles, the Tumba Equatorial Rocket Launching Station, was dedicated to United Nations. And what he said in that speech was, we do not have a fantasy of just like any advanced economically developed countries. But if we are to play a meaningful role in the community of nations, what we need to do, we have to be second to none in the application of advanced technologies to the real problems of man and society. And that is a buzzword here. This is a vision even today. For the last 60 years, ISRO has been progressing, a kind of service to mankind, and that has been the prime motto of ISRO's achievements. Next slide. So I've already mentioned how humbly the things have begun. These are some of the photos of first launch of Nike Apache in 1963 from Tumba, Trivandrum. And we also had the launching of further rockets from Russia and France as well. Yeah, next. Now, we talk about sounding rockets. Then we moved on to launch vehicles. We had a fleet of launch vehicles. Can you just, yeah, 1 second, go on. So it all started from satellite launching vehicle, SLV-3, and we have launch vehicle that is LV Mark III, where all our Chandrayaan launches have been launched. And to talk about launch vehicles, one thing which can come common to us is about the leadership, a team building. Because launch vehicles are very complex vehicles. A lot of components are there. I mean, it can be propulsion, it can be navigation, thermal controls, guidance, avionics, and whatnot. So many experts will be there over there, and all we need to have is a true leader who has to clearly manage, synchronize all these thoughts and beliefs without affecting their egos, but motivate them throughout. So a team leadership is underlying there when we talk about launch vehicles. To talk about an example of SLV, an incident of what has happened in SLV-3, I think many of us had read The Wings of Fire by our Kalam sir, where he has mentioned about some of the touching incidents he had during those times. Because when SLV-3, that was the first ever launch vehicle where India was striving to, was given the responsibility to Kalam sir by Professor Satish Dhawan, the chairman of ISRO during those times. He was slightly tensed, because he was so young to take up a great responsibility. But what Professor Dhawan had advised him is that you should not be tensed about the problems. You should captain your problems, and you try to resolve all those problems and succeed together, succeed forefront. So this is a kind of message which had really motivated our young Kalam, and he had taken the responsibility. But all of us know in 1979, the first SLV-3 had failed, having done a lot of works behind it, but still it was failed. And again, he had to face the media, and how we can do that. So what Professor Dhawan has said, that he took over to the media and said that my team had worked so thoroughly on this, but still it needs more technology to make it successful. I think he really had protected his subordinate there, and that is a kind of an exemplary leadership that Professor Dhawan had shown that point of time, and that vigor had made this team worked hard, and in another 1 year, we had the success of SLV-3. So this is a kind of leadership that has shown during those times, and we had a lot of visionary leaders in ISRO. That is how all these glorious achievements have been happening. Now we have our own launch vehicles to launch any number of satellites, any kind of satellites, from SLV-3 to ASLV, then PSLVs, GSLVs, LV Mark III, and even small satellite launch vehicles. We also have our own spaceport that is in Sriharikota, where the launch of rockets have been taking place. And why Sriharikota is because of the eastward launches and nearness to the equator. And again, why? Because you take a globe, when you try to rotate on your, when it rotates, you can see that at the equatorial region, the speed of this globe will be more, and we can utilize that speed for launching. So we need not spend more amount of fuel when we try to launch, have an eastward launch in the equatorial region, and that is why Sriharikota has been selected as our spaceport. Next. We also have a lot of other infrastructures now, vehicle assembly buildings, second launch pads, first launch pad, and all the launch pad and allied services. Yeah. Now, So what I've been mentioning about is that ISRO's prime motto is to for the life and the humankind. But can you ever imagine it can even save a lot of lives as well? As we can see in one of the disaster warning data which has been given for the cyclone which affected in our the coastal areas of Andhra Pradesh in 2022, which was the cyclone Azani, and the data that the satellites of ISRO could give such a way that many of the deaths could be avoided, because so those informations were enough to relocate all those inhabited people over there, and thereby we could save millions of lives there. Similarly, we can even have the flood mapping. We can clearly understand whenever floods, which all areas are more prone to the floods, which are the areas are more inundated, getting inundated during the floods and all. It can also talk about areas where we get more fishing zones, because by understanding the sea surface temperatures and chlorophyll concentration, one can clearly understand which all areas are more prone for the fishing zones, and that can really help our fishermen as well. So in this way, the applications of the satellites, we talk about, it can vary from even understanding about the natural resources that our Earth surface is having. We can give more ideas about where is the more crop yield getting, so that can help us in agriculture, fishing, weather forecasting, navigation, and whatnot. Next. So we have a lot of remote sensing satellites for doing all these applications. These are some of the names of those remote sensing satellites. We can have a lot of applications like Cartosat, which can clearly map our natural resources, OceanSat, ResourceSat, etc. And what about communications? Can we ever imagine that without a satellite we can survive today? Because communication, which is the essentiality of today's world, because without that we won't be able to connect the world. And the satellites are the prime reasons why we have all those possibilities of communications. Yeah, next. So moving on from there, you talk about teleeducations and telemedicine as well. Because teleeducation and telemedicine will definitely serve millions of people who is not having the luxury of highly specialized schools, colleges, or even hospitals. So these satellites will serve as a medium by which the specialized doctors can talk to the less privileged doctors in the rural areas, and thereby we can even help the millions of people, millions of patients in the hospitals, as well as schools where these children are deprived, many of the poor children who are deprived of this expensive education as well. And what not about internet services, satellites, telecommunications, and whatnot. So this applications of satellites is really touching the humankind a lot. We have been hearing a lot about ISRO in many of these news. We have recently heard the success of Chandrayaan-3. So I will be touching a bit on what we have done towards this mission. As we know, the moon, which is our constant companion, and is the first step beyond which the Earth, world beyond the Earth ever visited by humans. Lot of mining possibilities there, helium-3, water, and rare earth metals. And in fact, moon is going to be a future lunar hub. It can serve as an outpost for exploring the outer solar system. And of course, it's also have a pristine environment. A lot of preserved record of the origin of the universe is still there, especially in the South Pole where we have landed. We had Chandrayaan-1 in 2008. Many of the discovery-based experiments could be made there, discovery class results. We had a discovery of mini magnetosphere around the moon, which was given by one of the payloads in Chandrayaan-1. And it has found its place in geophysical letters as well. Next. Also in Chandrayaan-1, we could find the water in the atmospheres. And water ice was discovered on the surface by NASA's M3 instrument on board this Chandrayaan-1 as well. Now moving on from Chandrayaan-1 to Chandrayaan-2, we still had about 8 scientific instruments in that, and we could make many of these findings there, especially one of the most important achievement of this Chandrayaan-2 was that the orbiter could really understand, or in fact could map the entire moon, and a lot of scientific informations could be given. Even today, that orbiter is working successfully, but only failure was that we could not clearly land on the surface of the moon those time in 2019. And that was a failure. Probably this instrument, Chase-2 instrument in Chandrayaan-2 could detect the Argon-40, which is one of the great finding. And as I said, a lot of areas, terrains of moon could be mapped using this Chandrayaan-2 mission. Now, as we said, in Chandrayaan-2, there was a failure. So any successes will be followed from failures. And Chandrayaan-2's failure was actually a stepping stone for the success in Chandrayaan-3. And as I said, a lot of scientific information about the moon surface could be grabbed, and that was really vital for making our Chandrayaan-3 successful. And as I said, Chandrayaan-3 was to demonstrate the safe and soft landing on the lunar surface. It has to demonstrate the rover to rove around the moon and do so many scientific experiments. And it had a propulsion module which carried the lander and rover from the injection orbit to at 100 kilometers. And there's a photograph of this lander with the rover system. And a lot of, as we know, by this time, a lot of a lot of scientific informations would have come. Especially, there are so many payloads like the Langmuir probe, which could measure the surface plasma density. Then Chandrayaan surface thermophysical experiments, which could measure the temperatures from the lunar surface near the polar region. And there are some spectrometers in the rover which could gather information about the compositions of lunar soil as well. Yeah, there are other instruments for Chandrayaan-3, which was the lunar seismic activity to measure the seismicity, and the laser-based breakdown spectroscope, as I said. Next. So these are some of the historic images of what Vikram lander captured during the Chandrayaan-3 mission. Next. Yeah, then we moved on to the Aditya L1 mission to study the about the sun, and the idea was to send this Aditya towards the L1 point, which is called as a Lagrangian point, which is about 1.5 million kilometers from the surface of the Earth. It's basically to study the solar wind. And why do we need to study the solar wind? Because because the sun is actually spewing out a lot of particles, and we need to understand about it. This is called as solar wind, and this is about million tons of matter being spewed from the sun into space every second. So this actually influences our space weather, and we need to understand the dynamic conditions over this to clearly predict this space weather. And that is very important because of the space-borne and ground-based technological systems require this. Otherwise, this can get damaged because of the space weather. Next. And there are so many examples of space weather impact. Long back in 1859, there was a Carrington event where this disruption of telegraph has happened in no time, and nobody knows why it was so, because of space weather. And we really need to understand and predict this space weather for doing this. There were a lot of blackouts, then radio blackouts. Then recently in Starlink incident also was reported, especially during the SpaceX launch of 49 satellites. some of the satellites got really disrupted. It has got damaged because of this space weather. And we can also see a homing pigeon there, which actually finds its home by sensing the Earth's magnetic field. And once space weather impact on it, what will happen? The magnetic field get disrupted and it will lose its home as well. It will lose its direction. So these are some of the important influences, and many more influences are there of the space weather. To study that, we have had our Aditya mission, and it is on its way for success. Yeah. So in short, we can say the Indian space program, about 214 total missions, about 424 satellites of 34 countries have been launched. And we had a lot of successful missions like Mars Orbiter mission, Chandrayaan missions, Aditya, and a lot of experimental flights, demonstrations as well. So just to have a few insight into some of the small space, some of the missions which ISRO is taking up. One is the Gaganyaan, the human space flight. Probably yesterday you had heard about the successful demonstration of the crew escape systems of Gaganyaan, which is the first of its test in a number of tests. This was the first test which was conducted successfully in the first time itself. A lot of experiments otherwise has been done independently to make this rocket, that is launch vehicle LVM-3, to a human rated. And a lot of tests like static test of escape motors, the crew module deployment, etc. has been done. And so it's basically a harmony of engineering and human science and bioastronautics, all these areas, life support systems in the crew module, all these technology demonstrations has been happening to make our Gaganyaan module. That is to make at least 3 astronauts to travel in this for 7 days in space. So this is our task. Probably in a year or so, we will be able to get into missions of Gaganyaan as well. And a lot of other futuristic launch technologies like air-breathing propulsion, then reusable launch vehicle demonstrations, and so on. So there are many more important missions which is going to be taken up by ISRO. So actually a roadmap to the future. We'll have a HexpoSat in this year, 2023, to study about the polarimetry for studying the cosmic rays. Then the TVD-1 experiment, which had successful yesterday, probably you would have seen the news. We'll have a Gaganyaan launch vehicle, India's first manned space mission. Then we'll have a tie-up with NASA for synthetic aperture radar for remote sensing. And twin satellite mission to study the ionosphere and thermosphere of the Earth. And the Venus mission in 2026, then to a Mars orbiter mission, going back to explore the red planet, and many more. So there is an exciting lineup of space science mission for the future. So I'll just say thank you over here for your patience. And what I need to tell you is ISRO's glorious achievements. It can impart a lot of lessons of team building, how a team leader has to build, whether it is in any kind of projects, how a team leader has to be, and how cost effectively the technologies have to be demonstrated, and how the service of ISRO is going to help all of mankind. Thank you.